About 42,000 years ago, Earth witnessed a dramatic turning point in history. There occurred unusual electrical storms and widespread auroras accompanied by intensified cosmic radiation. The catastrophic climate shifts caused mass extinctions, and all of this was caused due to a temporary shift in the Earth's magnetic field. A planet's magnetic field is one of the most important factors that decide its fate. A loss of magnetic field can make a world barren, just like in the case of Mars. It can even cause the difference between life and death. The Earth's magnetic field protects us from cosmic radiation and the charged particles emitted by our Sun. As a result, a sudden change in the magnetic field's strength could wreak havoc on Earth, and something similar happened in the recent past. So what exactly happened 42,000 years ago? How did scientists discover the change in the magnetic field that occurred in the past? Finally, and most importantly, will something similar happen again soon? To begin with, let's have a look at the origin of the Earth's magnetic field. Most of the planets in the solar system are known to generate magnetic fields due to the motion of electrically conducting fluids inside them. And the same is the case with our planet. If we talk about the Earth's inner structure, there lies a region of iron alloys extending to about 3,400 kilometers. It is further divided into a solid inner core with a radius of 1,220 kilometers and a liquid outer core. As the planet rotates, the churning of hot molten metal around the iron core generates electricity that, in turn, produces magnetic field lines. These lines curve around the planet from pole to pole, creating the Earth's magnetosphere. A planetary magnetic field acts like a natural sunscreen for the planet. It helps in shielding it from harmful solar radiation. On the side that faces the Sun, the constant solar wind bombardment squishes the magnetic field. As a result, the field on this side extends to a distance of no more than 10 times Earth's radius, while it extends farther into space on the other side facing away from the Sun. The two spots where arcing magnetic field lines converge are the magnetic North Pole and the South Pole. Although these positions are relatively stable, the poles and magnetic field aren't fixed in place. Due to the changing forces, the field's strength keeps fluctuating, and about every 200,000 to 300,000 years, the field weakens enough to reverse the polarity completely. Such a recent magnetic field reversal is known to have taken place around 41,000 to 42,000 years ago. This event is known as the Laschamps Excursion. The fact that the magnetic poles flipped temporarily around 41 to 42,000 years ago was already known, but the impact of this flipping on life needed to be better understood. So, following up with this mystery, a recent study has connected this magnetic field reversal to climate upheaval on a global scale, and this resulted in mass extinctions and completely affected human behavior to another level. So what exactly happened, and how did the events unfold? Let's go along the lines step by step. In the previous studies, when researchers dated the Greenland ice cores back to the Laschamps event, the results didn't reveal any evidence of climate change. But when they turned their attention to another potential source of climate data, the results were strikingly different. Scientists have now started studying the bog-preserved kauri trees. The ancient kauri trees in New Zealand have been preserved in sediments for over 40,000 years, and an analysis of their rings can help to develop a long-term evolution of Earth's atmosphere. As the available data suggest, the Earth's magnetic poles swapped places for about 800 years before swapping back again. While they were migrating across the Earth, the planet's magnetic field dropped to only 0 to 6% of the current strength. As a result, the Earth was exposed to cosmic radiation due to the reduced magnetic blanket. The team cut cross-sections, or biscuits, from the preserved trunks of the kauri trees and tracked the changes in radiocarbon levels during the magnetic pole reversal. They specifically looked at changes in levels of carbon-14, which is a radioactive form of the element. Over the entire period of Laschamps reversal, this data was then compared with the tree's annual growth of rings. It helped them to arrive at an accurate and natural timestamp and allowed researchers to reconstruct the chain of environmental and extinction events, collectively called the Adams Event. As the magnetic blanket weakened, the encounters with cosmic radiation would have amplified, leading the way for the aurorae to light up the night skies. Also, the sharp increase in UV levels during solar flares would have forced people to seek shelter under caves. And this can explain the cave art around the world that appeared suddenly around 42,000 years ago. Further, when the team compared the newly created timescale with records across the Pacific, it hinted that the growth of ice sheets and glaciers over North America could also be related to the Adams Event. Even the megafauna across mainland Australia and Tasmania went extinct 42,000 years ago. Not only this, as per the new study, the Adams Event might also be related to the extinction of Neanderthals, which is an extinct species of archaic humans who lived in Eurasia until about 40,000 years ago. However, the most important thing is that the story doesn't end here. As mentioned earlier, the magnetic poles of the Earth are not fixed. They keep on wandering. The North Pole is currently known to possess rapid movement in the Northern Hemisphere. The Earth's magnetic field has weakened by around 9% in the past 170 years. And both these factors together point to a possible upcoming reversal. If a similar event happened today, the consequences would be even worse. The cosmic radiation would destroy our electric power grids and satellite networks. To make things even worse, the present-day atmosphere already has high level of carbons. This means that if a magnetic pole reversal takes place, the extreme changes in the sun's activity will invite even more terrible climate change consequences. Climate changes have been known to wreak havoc whenever things go out of hand, so it's high time we do something about our carbon emissions until such a catastrophic event knocks at the doors again.